Hello students, welcome to ST.SEBASTIAN Pre-University College. So in the last video we started the new lesson, motion in a two-dimensional. Now in today's class let us study about scalars and vectors. So in this video I am going to explain about the scalars and vectors, their properties in detail. Now let us study about what is scalars. So a scalar quantity is a physical quantity having magnitude only and no specified direction. So a physical quantity having magnitude only and no specified direction, then it is called a scalar quantity. Example: mass, length, temperature are some of the example of scalar quantities. Now in this slide you can observe that length of a car is 4.5 meter. Here length is a physical quantity, 4.5 is a magnitude. Magnitude means it's a number. So the length of a car is 4.5 meter. Here length is a physical quantity and 4.5 is its magnitude. Magnitude means its number. So here the length is a scalar quantity. Now let us see this next one. Mass of a gold bar is 1 kg. So mass is a physical quantity. Here 1 is the magnitude. So the mass is a scalar quantity. Now the next one, the time. The time is 12.76 seconds, where time is a physical quantity and 12.76 is a magnitude. So the time is also a scalar quantity. Now here you can observe the thermometer to measure the temperature. Temperature is 36.8 degrees Celsius. So the temperature is also a physical quantity. 36.8 is a magnitude. It's a magnitude in the sense it's a number. Now let us study about the definition of a scalar. A scalar is a physical quantity that has both magnitude. A scalar is a physical quantity that has only a magnitude, no specified direction. So some of the examples of scalar quantity: mass, length, time, temperature, volume and density. A scalar is a physical quantity that has only a magnitude, no specified directions. Examples: mass, length, time, temperature, volume and density. Now let us study about what is a vector. What is vector? Vector is a physical quantity that has both magnitude and specified direction. A physical quantity having both magnitude and specified direction is called vector quantity. Examples: displacement, velocity, acceleration, force and momentum. These are the examples for a vector quantity. Now in these slides you can observe that the position of California from North Carolina is 3600 km in west. So here the position is a physical quantity and 3600 is a magnitude, and in west it gives the direction. So a physical quantity which is having both magnitude as well as direction, such a physical quantity is called a vector quantity. So here the position is a vector quantity. Now let us see another example, a displacement. So the displacement from USA to China is 11,600 km in east. So here the displacement is a physical quantity, 11,600 magnitude and east is a direction. So the physical quantity which is represented by both of its magnitude as well as direction. So position, displacement, these are the examples for a vector quantity. Now let us define a vector quantity. A vector is a physical quantity that has both magnitude and a direction. Examples are position, displacement, velocity, acceleration, momentum, and force. These are some of the example of vector quantities. A vector is a physical quantity that has both magnitude and a direction. Now let us study about the representation of vector. A vector is represented graphically by a directed line. A vector is represented graphically by a directed line segment. The length of AB of the segment is proportional to the magnitude of the vector, and the arrow indicates the direction of the vector. Here, the end A is called the origin or tail of the vector, and the end B is called the head or terminus of the vector. Analytically, a vector is represented by a letter with an arrow over it as a vector AB. The magnitude of the vector is denoted as the modulus of vector AB or modulus of vector AB or AB. The magnitude of a vector is independent of the direction and it is always a positive. This is how we are representation of a vector. So A is the tail and B is the head. It makes some angle while it is traveling, so that indicates the direction. This is symbolically it is represented as the vector AB. Now let us see the representation of a vector. They are also represented by a single capital letter with an arrow above it. So here we can observe the different example. Vector A, vector B, vector P. These are the representation of different vectors with a single capital letter with an arrow above it. The representation of a vector. Some vector quantities are represented by their respective symbols with an arrow above it. For example, position is represented by the letter R. So it is the vector. In terms of the vector representation also we are using R representation, the letter R we are using to represent the position. Velocity we are using to represent the letter V. Force F. So while you are writing in terms of vector also we can use same letter to express those physical quantities. The vector R, vector V and vector F, these are the representation for a position, velocity and force. Now the next one, the types of vectors. On the basis of orientation, on the basis of their direction, we can types of vector. There is a different types of vector we are going to study in this video. Now the first one, parallel vectors. Two vectors are said to be parallel vector if they have same direction. So the two vectors here in the example we can observe that vector A and vector B, there is a two vector, they are parallel to each other and they are moving in the same direction. Such a vector is called a parallel vector. So parallel vector is a type of a vector. Here the two vectors are parallel to each other and they are moving in the same direction. Another example we can observe vector P and vector Q. There is a two vector, they are moving in the same direction. They are parallel to each other. Now let us study about equal vector. Two parallel vectors are said to be equal vectors if they have a same magnitude. equal. They should be equal magnitude. If the two parallel vectors are said to be equal vector if they have a same magnitude. So here equal vector, the two vectors it should be a same magnitude and they have to move in the same direction because these are the parallel vectors. Parallel vectors are moving with the same direction. So here equal vectors means the vector which is having same magnitude and same direction. So here in the example, vector A and vector B, they are same magnitude and they are moving in the same direction. Hence we can write vector A is equal to vector B. Another example, vector P and vector Q, they are also the same magnitude and they are moving in the same direction. Therefore we can write vector P is equal to vector Q. Anti-parallel vectors. The name suggests it is exactly opposite to the parallel vectors. Two vectors are said to be anti-parallel vectors if they are in opposite direction. So they are the two vectors, they are parallel to each other but their direction is opposite to each other. So here vector A and vector B, they are in the opposite direction. Another example, vector P and vector Q, they are also parallel to each other but they are in the opposite direction. So equal vector, parallel vector, anti-parallel vectors. So parallel vectors and anti-parallel vectors, these are exactly opposite to each other. The parallel vectors, the two vectors are moving in the same direction. Anti-parallel vector, the two vectors are moving in the opposite direction. Where equal vector, they are having same magnitude and same direction. Now let us study about negative vectors. Two anti-parallel vectors are said to be negative vectors if they have same magnitude. So the negative vectors in the sense when two vectors are having equal magnitude in the sense equal length but opposite direction. One vector is in the negative vector of the other. So one is in the opposite direction. Okay. So the two anti-parallel vectors are said to be negative vectors if they are same magnitude. So here in the example, vector A and vector B both are same magnitude but they are in the opposite direction. Hence vector A is equal to minus of vector B. So one vector is the negative of another vector. Vector P and vector Q, they are also same magnitude but they are moving in the opposite direction. Hence vector P is equal to minus vector Q. Next, collinear vector. Two vectors are said to be collinear vectors if they act along a same line. Vectors having equal or unequal magnitude but drawn in the same direction is called collinear vector. So collinear vector, they are equal or unequal magnitude but they are in the same line. Okay. So hence it is called a collinear vector. Collinear, that means they should be in the same line. So here you can observe the vector A and vector B, they are in the same line. Vector P and vector Q also, they are in the same line. So their magnitudes are equal or unequal but it is drawn in the same direction. Such a vectors are called collinear vector. Co-initial vector. Co-initial vector in the sense, here we can observe that two or more vectors are said to be co-initial vector if they have a common initial point. So here starting point of all the vectors are common. Then it is called co-initial vector. So here it is two or more than two vector. So here we have four vectors, vector A, vector B, vector C and vector D. There is a four vector. Their starting point is common. Their initial point is common. So it is called co-initial vector. Their starting point is same. Coterminous vector. So here Two or more vectors are said to be coterminous vectors. So we can observe that arrow indicates the terminal, or it is also called terminus, or it is called end point, isn't it? So it is a head. Arrow indicates the head or terminal or terminus. So here the two or more vectors are said to be coterminous vector if they have a common terminal point. So all the vectors, their terminal point is common, their head point is common. So here the four vector A, vector B, vector C and vector D, they are coming in the different direction, but they are joining, their terminus point is a common. That is called coterminous vector. Let us study about the next type of the vector. It's a coplanar vector. Three or more vectors are said to be coplanar vectors if they lie in the same plane. So vector lying on the same plane is called coplanar vector. They should be in the same plane. They should be lie in the same plane. So the three or more vectors are said to be coplanar vector if they lie in the same plane. So the vector lying on the same plane is called coplanar vector. So here the vector A, vector B, vector C and vector D, they are lying in the same plane. If they either they have to be in the one directional, or in the all the vectors it should be in the two dimensional. Now in this example they are all in the one dimension. So it is they lies in the same plane. Non-coplanar vector. Three or more vectors are said to be non-coplanar vectors if they are distributed in a space. So the non-coplanar vector, so vector are said to be non-coplanar vector if they are distributed in a space, if they are in the three-dimensional motion, like in the XYZ plane. So here the vector A, vector B and vector C, it is represented in the XYZ plane. They are in the three-dimensional motion. So such a vectors are non-coplanar vectors. Here the coplanar vector, the vectors are lie in the same plane, either in the one dimensional or two dimensional, but they should be in the same plane. Now let us study about the types of vectors on the basis of their effect. Till now what we studied about the types of vector on the basis of their orientation. So on the basis of their orientation we studied about the different types of vectors. What are they? Parallel vector, anti-parallel vector, equal vector, co-initial vector, coterminous vector, coplanar vector, collinear vector and non-coplanar vectors. Now let us study about the types of vector on the basis of their effect. The first one, polar vector. Vectors having a straight line effect are called polar vectors. The vectors whose direction is along the direction of motion are called polar vector. Example: displacement, velocity, acceleration, force and linear momentum. These are the example for a polar vector. So the vector whose direction is along the direction of motion, so they have the straight line effect. Such a vectors are called polar vectors. The second one, axial vector. The vectors having rotational effect are called axial vectors. The vector whose direction is along the axis of rotation are called axial vectors. So here we are having a rotational effect. Examples: angular velocity, angular acceleration, torque and angular momentum. These are the example for a axial vector. So axial vector having a rotational effect, where polar vector having straight line effect. Now let us study about vector addition, geometrical method. How we can add the vectors? We cannot add the vectors directly, same as the while you are adding the two numbers, 2 plus 3 is equal to 5, isn't it? We like that we cannot add the vectors. So to add the vector we have to follow some rules. So addition of vector, for the addition of vector we are following. So vector addition, since the vector possesses directions in addition to their magnitude, they cannot be added by the simple rules of algebra applicable to a scalars. So that rule is applicable for only for a scalar, not for a vector. Vector addition can be done either graphically or mathematically. The addition of a vector A and vector B can be written as vector C is equal to vector A plus vector B, where vector C is called a resultant vector. The vector C acting along has the same effect as the component of vector A and vector B acting together. There are three laws of vector addition, namely triangle law of vector addition, parallelogram law of vector addition, polygon law of vector addition. These are the three types of law of vector addition. Let us see the first one, triangle law of vector addition. It states that if two vectors can be. Now let us study about the triangle law of vector addition. It states that if two vectors can be represented in magnitude and direction by the two sides of a triangle taken in the same order, then the resultant vector is represented completely by the third side of the triangle taken in the opposite order. So here there is a two vector, vector A and vector B. It is represented both in magnitude and direction by the sides. And the third vector, that is a resultant vector C, it is represented by the third side of the triangle taken in the opposite order to these two vectors. See, the vector A and vector B, it is moving in one direction and the vector C is moving in the opposite order. That is the triangle law of vector addition. Now the next one, parallelogram law of vector addition. It states that if two vectors can be represented in magnitude and direction by the two adjacent sides of a parallelogram drawn from a point, the resultant vector is represented completely by the diagonal of the parallelogram passing through that point. See here, vector A and vector B, the two vectors, they are adjacent side. The vector A and vector B, they are adjacent side to each other. Then the resultant vector we can get in the diagonals of parallelogram. So the vector C is equal to vector A plus vector B. So the third type of the vector addition is the law of polygon of vector addition. It states that if a number of vectors are represented in magnitude and direction by the sides of polygon taken in the same order, then their resultant vector is represented in the magnitude and direction by closing the side of the polygon taken in the opposite order. So these are the three types of vector addition. First one is the triangle law of vector addition, parallelogram law of vector addition, and the third one, law of polygon of vector addition. So here the polygon of vector addition, it states that if a number of vectors are represented polygon vector, so it is applied for a n number of vectors. So the number of vectors are represented in the magnitude and direction by the sides of polygon taken in the same order, but the resultant is represented in the opposite order, same as the triangle. So here the two vectors, they are in the same order, but the resultant vector C is in the opposite order. Similarly, the polygon, which is applied for a n number of vector, where the vectors are in the same direction, but the resultant vector is in the opposite order, and it is in the closing side of the polygon. Parallelogram vector, it states that the two vectors are they are adjacent side, but the resultant vector is drawn in the diagonals of parallelogram. Now, commutative property. Therefore, the addition of vectors obey the commutative law. Commutative law, here the vector A and vector B, and the resultant vector is vector C. And in another diagram, you can observe the vector A and vector B. So here the vector B is added to the vector A, so the resultant vector is vector C. Therefore, the vector C is equal to vector A plus vector B, that is equal to vector B plus vector A. So it obeys the addition of a vector which obey the commutative law. A plus B is equal to B plus A. So the vector which obey the commutative property, commutative law. The vector is also obey the associative property. If there is a three vector, vector A, vector B and vector C, then the resultant vector D, we can write the vector D is equal to, it's the sum of vector A plus vector B, that plus vector C, that is equal to vector A plus, we have to add those two vectors, vector B plus vector C. So first we have to add the vector A and vector B. You will get the resultant vector is the sum of those two vectors, that is vector A plus vector B. We have to add this vector A plus vector B with the third vector, that is vector C. Then you will get vector A plus vector B, that into plus vector C, that we have to write in terms of bracket, that is equal to, in the second diagram, first we have to add vector A with the vector B plus C. First we have to add vectors B and vector C. While adding vector B and C, you will get the resultant vector B plus C, vector B plus C. The vector B plus C is we are going to add with vector E. Therefore, the resultant vector you will get in the D. The D is equal to vector A plus, in bracket, vector B plus C. So vector D is equal to, in bracket, vector A plus vector B plus vector C, that is equal to vector A plus, in bracket, vector B plus vector C, close the bracket. So the addition of vectors obey the associative property. Now the subtraction of vectors. The subtraction of a vector B from vector A is defined as the addition of vector minus B vector to vector A. Okay, so here vector A minus vector B is equal to vector A plus, in bracket, minus of vector B. So here the vector minus B is a negative of vector B. It has the same magnitude, but the direction of vector B is opposite. So here the subtraction of vector B from vector A is defined as, it is the addition of vector minus B to vector A. So vector A, vector B, vector, the resultant vector is vector A plus vector B. But in the subtraction, vector B, it becomes minus vector B, and we have to subtract with the vector A. So you will get vector A minus vector B. So vector A minus vector B is equal to vector A plus, in bracket, minus of vector B. Now let us study about vector addition by analytical method. Vector addition by analytical method. Now we have to study with the magnitude and direction of the resultant of two vectors. So this is the derivation of the magnitude and direction of the resultant of two vectors. So in this magnitude of resultant of two vectors, let us consider a two vector, vector P and vector Q respectively, making an angle theta with each other. From the parallelogram law of vector addition, the diagonal OC of the parallelogram OACB represent the resultant vector. Vector R is equal to vector P plus vector Q, where CM is a normal drawn from C to produce OA. From the right angle triangle OCM, we can write OC square is equal to OM square plus CM square. That is by using the Pythagoras theorem. From the right angle OCM, we can write OC square is equal to OM square plus CM square. OC square is equal to OM square, which is equal to OA plus AM whole square. OA plus AM whole square plus CM square. Now this is in the form of OA plus AM whole square, that is in the form of A plus B whole square formula we can apply. That is A square plus B square plus 2AB cos theta. So A square plus B square plus 2AB. So here OC square is equal to OA square plus 2 times OA into AM plus AM square plus CM square. So that can be written as OC square is equal to OA square plus 2OA into AM plus AM square plus CM square, AM square plus CM square, so that we can write it as a AC square. OAM square plus CM square, that is equal to AC square. That we have to from the triangle, triangle CAM, that we can write it OA square plus 2 OA into AM plus, instead of AM plus CM square, we can write it is AC square. From that triangle CAM. Now let us take the triangle CAM. For that triangle you have to write the cos theta is equal to AM divided by AC. The cos theta is equal to adjacent side by hypotenuse, AM by AC. Therefore AM is equal to AC cos theta. Now in the first equation, that is OC square equation is there, no? In that equation, instead of AM you have to substitute the value AC cos theta. Now after that we have to substitute the value OC, which is equal to resultant vector, that is R, OA which is equal to P, and AC which is equal to Q. Therefore R square is equal to P square plus 2P into Q cos theta plus Q square. R is equal to the square root of P square plus 2PQ cos theta plus Q square. So this is the expression of magnitude of resultant of two vectors. So we have to take the two vector P and vector Q. It makes an angle theta with each other. From the parallelogram vector addition, in the diagonal OC, we will get the resultant vector R is equal to, it's a sum of vector P plus vector Q. Now let us take the triangle OCM. So to solve this magnitude, we have to draw one perpendicular line to the C to produced in OA. So it makes an right angle OCM. After that, apply the Pythagoras theorem. OC square is equal to OM square plus EM square. OM square can be written as OA plus AM. After that, we have to OA plus AM whole square, that is in the form of A plus B whole square. A square plus B square plus 2AB. That formula we have to apply it. Now OC square is equal to OA square plus 2OA into AM plus AM square plus EM square. So here AM square plus EM square, which is equal to AC square, from the right angle CAM. After that, in a triangle CAM, the cos theta is equal to adjacent side by hypotenuse. So that is AM divided by AC. Therefore AM is equal to AC cos theta. After that, in the equation OC square, instead of AM, you have to substitute the value AC cos theta. OC square, which is equal to R, OA square, which is equal to P, AC, which is equal to Q, that you have to substitute. Therefore, the magnitude of resultant vector you will get R is equal to square root of P square plus 2PQ cos theta plus Q square. Here P and Q are vectors and theta is the angle made by the vectors. So this is all about the magnitude of resultant of two vectors. The direction of resultant vector I am discussed in the another video. Thank you, students. If you have any doubt, you can text me in the WhatsApp. Hope you understood the concept. So you have to watch the video twice so that you can understand the concepts clearly. Thank you.